a student of BTech CC third year at the Rodias University. Currently, I am doing internship at Bennett University. I got this internship through the Leading India AI, and I am working on the project Human Activity Recognition. This project is all about the recognizing the human activities in different fields. It is an Sadak Hawaii locomotion challenge, and this human activity recognition has different applications such as real real time monitoring, localization. In localization, we use mobile sensor in place of a GPS because sometimes GPS signals are not available everywhere. So that's why we are using mobile sensors in this localization. And other application is like manufacturing industry. And I'm working this project in a team of 4 members. That's me, Sai Sumant, Ankit, and Sanjana, under the guidance of our mentor, Mr. Balmukund sir. And that's this word to Sai Sumant.
Ready? Hi, I'm Sumant. We are currently working in the Six Hawaii Locomotion Challenge. And coming to the data set, the data set is provided by the Sussex Hawaii Locomotion. The data is collected from United Kingdom, from the University of Sussex. Well, in this, basically the data set is acquired from the sensors which are placed at the different parts of the body. Like, see here we can see like the body one, the torso, the hand, the back, and the pocket. So these generally collect the same data like acceleration, linear acceleration, magnitude, orientation, pressure, uh, and such thing like that. Like the phones are generally embedded with these sensors like accelerometer, gyrometer, and etc. Well, in our data set, we need to detect 8 activities like the person, like the sensor captured a person's activity, right? So the activity should determine the 8 of these, one of 8 of these, like still, is the person still or walking or running, is he on bike, car, bus, train, or subway. Therefore, thereafter, we have actually a data set which consists of 196072 samples of 500 features each, which just determines basically it's a 5-second action which is taken at 100 Hz frequency. So finally, we need to compute what the actual activity performed by the person in the video.
So basically, data is given in such a way that the rows are in around 2 lakhs and we have 500 columns, and the labels are also in that way. So for processing the data, we took like for a frame, for a 5-second frame, like Suman said, we took the maximum occurrence activity that occurred in that frame. So that is the label part, and for the data processing part, what we did was, actually when we were trying to fit the model as it is, the raw data, it was actually overfitting on the model. So for that, to reduce the overfitting, we used the few techniques so that it can be beneficial for reducing the overfitting. Some of the techniques were the overfitting actually happening the most in the acceleration and the magnetometer data. So to reduce that, we use the rotation matrix R, that is for changing the orientation from the phone coordinates to the northeast down coordinates. And the orientation matrix is basically given by this. So we basically multiplied the orientation matrix with the data actual, and we got the actual the data that we want to use for the model. And the other thing is one of the orientation, like actual orientation, how the person is standing or the way he's standing. So basically that is given in the quarter neons. That is basically one of the coordinate system, and it is beneficial only if all of those coordinates in the quarter neons are used at the same time. But in our model, what we want is all of them to have a separate meaning, and that can be understood easily by the model. So for that, we use the Euler's angle. We change the orientation to the Euler's angle, pitch, roll, and yaw for that. And after pre-processing the data, we used the feature extraction part. For that, we used two things. One is the correlation, how much is the data correlated with each other, like how much is the feature correlated. So for that we used some of the values like zero point 0.8 or we can say zero point 0.7, zero point 0.7 to zero point 0.8 values. For that, if there are any correlation that is higher than the 0.7 or zero point 0.8, we deleted that part. And for the feature extraction, we used the tree classifier that gives actually what are the features that are giving the most, which are affecting the most on the label.
Hi, I'm Sanjana and I'm here to explain the model part of this project. As Ankit explained, the features of the data set was extracted using the feature importance and the correlation. And the model we have used two models, that is the LSTM model and a CNN with LSTM1. Both of the model consist of 7 input layers, specifying that the inputs of each sensor data is given to the input nodes of the model, and the input node receives the data and which process the data separately. That is, the 7 data from each sensors have been processed separately, and then then the result from each node is being concatenated to find the final label of the action that is being performed in the frame. And then the data, the output from both the models is being compared. That is, the output from the LSTM1 and the output from the CNN with the LSTM model is being compared, and it is found that the LSTM model worked better than the CNN with the LSTM model. Because the validation accuracy and the training accuracy of the CNN with the LSTM model was prior lower than the accuracies of the LSTM1. Hence, we chosen the LSTM model for this dataset challenge. And the output of this label is being converted into a text file, which consists of 500 rows again, as specified in the dataset challenge. So we hereby conclude that we used an LSTM model to find the stop, please. I conclude by saying that we prefer an LSTM model for this Sussex Hawaii dataset challenge.